We're talking about the three forms of a quadratic equation. Now there are three ways that you can write any one quadratic equation. We talked about these in class today. Standard form is ax squared plus bx plus c. And I'm putting it equals 0 because we're going to start talking about solutions, and the solutions we're talking about right now, we have to have it set equal to 0. The second form is factored form. This is what we get when we factor standard form, and that is a times x minus r1 times x minus r2. Now the r's stand for roots. Remember, roots are the same thing as x-intercepts, zeros, or solutions. And so r1 and r2 just mean the first root and the second root. And then we have vertex form. Vertex form is in the form a times x minus h squared plus k, and again I set it equal to 0. So these are our three forms, and we're going to look at what we can get from each one of these forms. Now, in each of the three forms, there are three things we can identify about the particular graph. In standard form, we can identify concavity from the sign of A. So just like we did before, if A is positive, it's concave up. If A is negative, it's concave down. And we know for a fact that we can do that with vertex form because that's where we learned it. So what I'm telling you here is that we can do it with all three forms because the A value is going to be the same no matter what form we have it in. Okay? Second thing that we can identify from all three forms is the axis of symmetry. Now here it's a little bit different for each equation, each form. We learned when we were doing vertex form that we could find the axis of symmetry just by finding the h value. X equals h gives you the axis of symmetry. Well, for standard form, we have a little equation, negative b divided by 2a. Now that b and the a come from standard form. So the a value from in front of the x squared goes on the bottom, and the b value in the middle in front of the x goes on top. And that will tell you the x value of your vertex, so x equals that number is your axis of symmetry. Now, for factored form, it's a little bit different because we've got the two roots, and as we saw yesterday on our activity, or today on our activity, the vertex is exactly in the middle between the two x-intercepts. So here we can use this equation, r1 plus r2, we're getting that directly from our factored form, divided by 2. We're basically just taking the average between those two x-intercepts. So all three of the equations are different, but make sense if you think about them for each factor or for each form. The third thing we can pull from all three forms is a point. Okay, from standard, we found today that we could find our y-intercept from standard form, and that's always going to be in the form of 0c. And on factored form, we can find our x-intercepts. Oops, sorry. I'm going to move this over a little bit. We can find our x-intercepts, and those are going to be in the form r1, 0, and r2, 0. Again, we're pulling those numbers directly from the equation. And vertex form, we know that we can find the vertex, and that is the point h, k. All right? So from every form of the equation, we can find concavity, the axis of symmetry, and some point on the graph. Okay, the a value. The a value is going to be the same number in all three forms. All of them that we dealt with today were ones or negative ones. Of standard form, just a moment. Okay, if we have standard form 2x squared plus 8x plus 6, the factored form is going to have the same a value as the standard form, and that's the 2. Here's factored form. And then the vertex form is also going to have an a value of 2. right, so the a value doesn't change, so whatever your a value is in one, we need to be sure that we put that same a value in the rest of them. Now, this a value of 2 is actually giving us the following information. If we remember from our transformations, we have a vertical stretch by a factor of 2. Which means it's going to get skinnier. It is concave up because it's positive. And so our graph is actually going to look like we have a vertex at negative 2, 2. We have x-intercepts at negative 1, negative 3. And we have a y-intercept at positive 6. So it is steeper than our parent function, and it is concave up, and I get that all from the a value of 2. So be sure that you are comfortable with all of this information.